Okay, so there's no actual slides, as I was invited last minute for some more keywords to me to rant for 10 minutes and invite some possible questioning. I could change my title to, I think it was conditional recall plus information markets is my sleeper word. But I generally have been calling things under an umbrella of CGI or cooperative general intelligence. How does this work? Oh. Okay. This is a little bit off topic. It's more of a question. Something I wonder about is we are barreling toward this ASI feature. Are there any structural benefits to retaining dispersed information over having a single monolithic intelligence with access to all information simultaneously, even assuming that that intelligence can simulate holdout information? And I don't have a good answer to this, but yeah, kind of haunts me. So the foundation for pretty much everything I want to talk about is agents plus commitments. This assumes agents running in trusted execution environments. It could also just be run in the cloud with trust assumptions, but generally an environment that doesn't leak its information. And additionally, you need to add in monitoring mechanisms because T's are not enough to guarantee more complex behavioral commitments. And so you essentially need like competitive markets to enforce these commitments. Important primitives that you get from agents running in T's with behavioral commitments. One is forgetting, which is essentially equivalent to conditional recall or a lot of mechanisms in NVAI. To illustrate this, if you have a human or two humans operating in an information market, and a seller needs to convince a buyer of the value of information, the buyer looks at that piece of information and cannot reliably forget. There's no Men in Black amnesia scanner or magic pill to make sure that the prospective buyer of the information forgets that they've seen this piece of information. Agents, or at least like agents running in T's with behavior commitments, can engage in this type of information market where they look at a piece of information, and if they decide to not purchase that information, they destroy that context and prove that they destroyed that context. That alone is an extremely powerful primitive that it enables sort of like alternate approaches to all of these things that previously would have been walled off to the arrows information paradox. A variation on that is bounded information extraction. So in this case, instead of looking at a piece of information and destroying the context, you have an agent that is operating a task over a piece of information with a rule such that they can only have a bounded extraction of that information. An example of this, it's like sort of wishy-washy, but to illustrate it is, say you're a VC, you're technically dumb, you need a PhD in material science or something to contribute to your due diligence process to test the viability of a startup's proposals. You have your due diligence agent operate in a trusted execution environment and buy the right to access all of the private context of this material scientist. But maybe that agent can only output a number in the range of 0 to 1. So in this case, the researcher's information remains private, but the VC is able to execute this task over that information, pay to execute over that information, and output this 0 to 1. Even in this scheme, the information is leaked. Like each time we run one of these tasks, you have to measure the amount of information that is leaked, even if it's as simple as a binary answer. But this also sort of like opens up this new primitive of private information remaining in pockets and agents executing over that information and staying private. Another primitive that it's really kind of just a combination of forgetting and bounded extraction is this concept of an agent that is operating over a superset of state in a system. So this means you have agents running around doing whatever, operating on behalf of some human principle, making money in DeFi, buying and selling couches, who knows? And then you have another class of agents and multiple classes of agents that are able to do one of two things for both. One is inspect the internal state of another class of agents, see weights, see actions, essentially see like everything in their environment, with a guarantee that they do not leak that state, right? So like, in current world, this is Anthropic is able to watch what they're doing and watch what you're doing with Claude, and they have their classifier, says, oh, you're doing a cybersecurity thing, you're banned, stuff like this, right? In this example, it would be some custom agent is running in a trusted execution environment and is able to look inside the other agent's activities, or additionally look through various parts of these information resources that all were made private. Those three things compose in interesting ways with attribution incentives, decision markets, challenge markets, auctions, and potentially things that are weirder than markets, like neuronal connections between different pockets of information or different agents. That's more speculative. So anyways, when you compose those primitives with the markets and mechanisms that I just mentioned, it enables a whole bunch of interesting things, and I'll just illustrate a few. One, which is sort of like most obvious, is private information markets. I already gave one example of this, like expertise markets. That was the example where you're a material scientist, you have your, all of your AI context or unpublished research or whatever, and a buyer is able to purchase from that, either to buy your context outright or to execute a task with that information. This is sort of related, but you could do private evals. Another thing that I guess kind of relates to the neg information is there's a lot of failure traces that are very valuable, like data that companies produce or researchers produce that never become public. And there might be good reasons why they can't become fully public, but they might be purchasable in a selective way to help another process that essentially like isn't revealing that failure information, but helps to route the decision making in this other process. Another example here, kind of related to expertise markets, but it's information dark pools. This could be, it could be the nasty form of you have non-public information that you shouldn't be leaking, and like some rogue traders buying from it, or it could be simpler, like you see something happen in the city, maybe you see like an ambassador go into a bar in Washington, D.C. with a senator. You take a video of this, you put this in your encrypted storage, and a prediction market bot is able to inspect this, decide if it wants to purchase this information, and then buy it and use it to trade on. Another fun one is hiring markets. So in this example, you kind of get like two nice qualities. One is this sort of feedback. If I step further, yeah. One is, say you're working for OpenAI, you're willing to leave to Anthropic. You don't want OpenAI knowing that you're talking to recruiters, you're willing to leave or whatever. That's quality one. Quality two is you could conceivably put all sorts of private information that you wouldn't want to leak in sort of this like hiring dark pool. So essentially what happens is you put your super resume, right? Like this could be your resume. It can also be every piece of code you've ever written, every work communication you've ever had. Ideally, in the future, this is like receipt based, so it's not spoofable. Like every time you take a work action, there's a receipt that like you sent that message, you completed the task, etc. But anyways, the idea here is that because this information is never being made public, all of this can go in this sort of like encrypted environment. And you also have essentially like your negotiation terms. And on the other side of it, you have companies that are, looking to hire certain profiles. They have their agents can go and inspect your sort of like super profile and negotiate with you, and then decide whether to either like pull you into a human recruiting process, like pay for this, or recruit you. That the actual sort of like hiring would probably be dependent on having this like receipt mechanism, so that it's like not scrutable, but you get the idea. Another thing you can do, information market related, is like risky social matching. So I'm not sure that there's proper advantages over everyone actually having their custom agent in this sort of like dark back room, using it for like risky, open preference dating matching to euphemize it, or other sorts of social coordination. It may be simpler to just have sort of like custom software running in a T, but similar case there. Okay, then a little bit harder to illustrate, but I find it interesting, is competitive oversight. So the idea here is, I guess there's a few categories of it. One is mechanisms to essentially like enforce safeguards or even like the commitments themselves. So here you have superset state agents that are able to look at what the other agents, like all of their internal state. And you have mechanisms such that different superset agents can essentially like compete to either sort of like provide a safeguard or positively align the other class of agents. So the safeguard would be, well, this agent has committed to operate under a certain behavioral commitment. We think they are breaking that behavioral commitment. The behavioral commitment could be forgetting, or it could be, don't try to attack another agent in this environment, like something like this. The positive case is sort of like having these other agents watch the agents and decide, okay, you've spent enough test time compute, generate your answer now. Or I know of a pocket of information or another agent over here that would be super additive. You should go by that piece of information. Things like this, where you can have different agents that are sort of like looking at a superset of state in the system, help to optimize individual agent or combination of agent like policy choices over time. Routing is sort of a variant of that, a little bit more specific. One thing you can do with these private sort of like forgetting agents is you do interesting things with reputation, or just like routing using transaction histories. Reputation, I guess, like one way to illustrate it is just like in a human environment, there is sort of like social friction with providing negative reviews, and there's also a difficulty to monetize reviews if they're like immediately publicly available. So in this case, all of the reviews and ratings are staying in this private environment, but you still have agents that are able to purchase from these ratings and reviews in order to more effectively route other agents or humans. Sort of a richer example of this is the idea that sort of like an entire transaction graph could be purchased in this way. So you have like many buyers and sellers of a particular good. That entire graph could be inspected by routing agents without leaking the graph, or having like a bounded leakage of the information that's contained in that graph. And that can be used to more effectively route between buyers and sellers. Then, and I think this is sort of in the conditional recall paper, like deeper into it, but essentially what you get with agents operating in T's that are guaranteed to forget is program equilibrium options. So like for negotiations, like say the two agents are negotiating like hiring terms for, maybe it's like some sort of supplier auction. The agents can But I guess like do one of two things. One, they could reveal their entire program strategy to each agent from the beginning and find sort of like the optimal equilibrium. Or, and this is what's in conditional recall, they can do these like branching negotiations and forgettings, but essentially find solutions to negotiations that wouldn't be able to be found otherwise. I think the high level here is that currently we have a wall between what markets can do and what firms can do. And with new institutions and agents with these primitives, we can open sort of like a spectrum between markets and firms. Markets are very effective at aggregating dispersed information, but they collapse that information into a price in order to preserve the privacy of the information. And firms enable trust and operating of private information, but are very inflexible. And with sort of like the primitives we just talked about, there's sort of like different information market structures that are neither firm nor market that collapses price, that I think will be sort of like much more optimal and open more possibilities in the Asian area, under the condition that we don't get to ASI and then this monolith condition takes over where dispersed information is actually maybe inferior to just like the monolith seeing everything. Obviously, there's a ton of problems with all of this. Aside from just the complexity of running larger and larger agencies, commitment enforcement is like a cat and mouse game, like basically a not solvable one. So it's one thing to have like a very simple commitment of like, you know, here's an attestation, information is not going to lead to this trust execution environment. It's another thing to have more complex commitments, like you look at a piece of context, you forget it, or you operate under certain negotiation rules, and to also make it robust when you assume a multi-agent environment where agents can be side channel attacking other agents, or sleeper agents can, you know, arise, because the assumption here is that these are all open weight agents running in private environments. So I guess you kind of have to break down commitment enforcement into three broad categories. One is the category of things that you know, T attestation can probably solve. Another is the category of things where having a deterministic program essentially inspect a given output and sign a key to enable that output to actually do the tool call or whatever is sufficient. And then there's like a much larger and harder category where I think the flexible solution is to have competition between these monitoring agents, essentially like detect misalignment, rule breaking, super agent, you know, like whatever, where they're watching these agent activities, not leaking information. And like one sort of like simple example would be like a shelling coin game where every agent in the system has value at stake. And one of these sort of like monitoring agents could stake value on a flag of there's been misbehavior here. And then you would have like an escalating, other agents could either stake value on, yes, there was misbehavior, or, you know, there was not a misbehavior. And the winning side sort of like earns both the stake of the original agent and the stake of the opposing side, assuming there's like a eventual resolution. I think that that's can provably not be the only mechanism in every case. Like even with whatever magical mechanism that you build to enable this like competitive oversight, you always will need some escalation condition where the activities become public, like they leave this private environment, and there is an external judge that sort of like then evaluates the ground truth of the condition. But hopefully you very rarely,
I'm saying 2 minutes.
Okay, very rarely trigger that. Attribution complexity. Yeah, like Shapley is optimal for a lot of this, but computationally a nightmare. Everything else is a trade-off. Using markets for immediate attribution doesn't have sufficient look ahead, so it's limited. And then I also mentioned it, but like this is not as important as the commitment enforcement or attribution complexity, but it's important to measure bit leakage because every action within one of these private systems is still going to reveal something to an observer about what's contained in the system. Okay, I'll not get into either of these.
Any questions?
Yeah, I find all of these ideas super interesting. I definitely think about them in theory, it make a lot of sense. I think in practice though, and I know you said that like constraint enforcement was like this like game of cat and mouse, but most of the interesting agent stuff, or believe it or not, leaving even LLMs outside, but most of the interesting use cases are so fuzzy. It's very hard to impose and key constraints, and I feel like keeping information exclusive and having it properly because it's very, very hard. I don't know if you have some sense of where the frontier is, or for some reason to be optimistic. It'll be good at going beyond just TEs.
I mean, I guess like practically in terms of testing this, we're not even at any sort of frontier. So it's who knows what actually happens when we start trying to use these things. I think that a lot of the commitments are fairly quantifiable, and then the fuzzier ones, you need to test competitive oversight of the commitments. I mean, it's essentially like an Oracle problem. You don't want a fuzzy resolution mechanism. But yeah, I think a lot of what you want isn't all that fuzzy. I mean, that's like a longer conversation.
I've got a question. Does anyone else have a full question? Yeah, it's very tough. A bunch of familiar ideas, being flashbots and some new ones. My question is actually a little bit less about the talk, so sorry about that. I was wondering if you could relate this maybe to the concept of neg information, the previous one.
Yeah, so I mean, like one like example is like right now I'm a little brain fried because I, like many people, caught AI math psychosis like 2 months ago. And a lot of the time toward getting an actual solution is, of course, just like crossing off all the things that don't work. So in research, for example, it would be really valuable to have this information dark pool of all of the failures toward a given proof or towards some given outcome, and to be able to have the process use all of these private failures to cross off routes, toward like a positive route. Another example would be like coordinating AI research. Like we're spending billions and billions on, training rounds and whatnot. I guess like all the AI labs are competitive, but conceivably there might be some information that one lab has that, enables less compute waste, things like this. So I think there's like a lot of value in mechanisms like this to take in all the neg information and still operate on it without necessarily making it public, which I guess like contradicts with the neg information thing.
Cool, sweet. Yeah, I never even thought about all the failed proofs. That's neg information. That's just interesting. Cool. Well, if that's it, thank you very much.